Yes, I'm going to present a common project, I would say a common issue that our cluster Anthropisation, natural hazard and ability is working on. It's related to archeosismology. I think it's quite important that I mention that archeosismology is not something new. But in fact, it was mainly dealt by two disciplines in the past, I would say. One is from the geoscience disciplines. In fact, it was to reconstitute the chronology and the history of earthquake in different areas. But one part was still missing in between what is called the paleosismology and the historic and later on instrumental seismology. So you can consider that archeosismology is taking building, and in particular cultural heritage building, as a kind of samples, like ice samples for climate change. It's something more or less, I would say, equivalent, and so on. This was I would not say the first, because I don't know exactly where first, if it was geoscience or archaeology. And the other definition or the other approach of archaeology was coming from the archaeological sciences, where in fact archaeologists, when they excavate or discover sites, they discover that in particular areas, especially area prone to earthquake, regular earthquake, building have had singularity, something very specific that people don't know. And it's, as you will see, not only building, sometimes even cities, or at least block of buildings. And more recently, new sciences came into this field. I'm talking about architecture, because we see this as a potential resource for re-engineering of historical solutions based on local resources, local knowledge. But also now we have civil engineering field for, I would say, the part of modelizations and experimental work that we intend to, and we have started to develop. So the first things we did was part of the what was the CDP project, where we had cooperation amongst us, amongst the three main labs that are involved, ISTER for geoscience, 3SR for civil engineering, and AECC Crater for the architecture. But we were already linked with a certain number of project research team in the south, Latin America, I forget to mention here, but also Central Asia, and also from university in UK and Spain. And now we also find out that France has sites which could be also useful for this type of approach regarding archeosismology. And one important step was the PhD that we had in common with ISTER, the PhD of Dr. Andy Combe, who did his research on the archeosismology on the Machu Picchu site, to try to describe the not the singularity, but more certain types of stone movements, stone cracking, that was probably caused, and it demonstrates this, caused by earthquake. And to put it in relation with the archaeological knowledge of the site, to see how if it corresponds to known earthquake or something that was not known at these periods, that need to inform the seismologists of today. The perspective of this, I would say, thematic is the huge collaboration that we have implemented through another project that I'm going to explain, mainly with as part of the strategic scientific partnership with the University of Oxford and with other researchers. What is known in terms of archaeosismology is that we know quite well nowadays about stone masonry. And when I'm talking about stone masonry is regular stone masonry. We don't know exactly how does it work for dry stone masonry. I'm sorry if I use maybe some very specific things coming from my field, but we don't know, for example, lots of things about geo and bio building traditional materials. In particular, earth constructions, which represent at least 50% of the cultural heritage in our planet. 20% of the World Heritage Sites on the UNESCO list are made of earth, but there are much more coming, especially the ancient city in Central Asia. The perspective, as I was explaining, is to do some re-engineering, and that means to reuse these techniques with some possible improvement and adaptation to the new conditions in certain territories, and to go to localize the vulnerability reduction strategy, either for human settlements, but also for cultural heritage sites. The ambitions, I would say, is also to see if the tools and the methodology that we are developing, we are going to develop, can be applicable to other type of hazards that are not geohazards, but hazards due to climate change, because we know that some certain ancient cities were abandoned due to change of climate, raining activities, etc., etc. So this is an idea also to develop, to see how methodology that we develop can be applicable. And also we have to think about the vulnerability of specific cultural heritage sites that are excavated by archaeologists. This is a combination between the archaeological work and conservation work of these cultural heritage sites and so on. One interesting thing that you have illustrated here on this slide is the intention also is really to do research that has a social impact. And we have one example here. The result of the research of Andy Combe, this PhD, developed into a kind of booklet for children in the school of Peru, after the example to explain and so on. That means also to provide some information about the knowledge of earthquake and culture of risk with local partner. Back to what I was starting to explain, for example, in the Minoan civilization in Crete, in the Bronze Era, which is a long time ago, in fact, the seismic risk was not taken only at the level of an individual building, like you have this illustration with the cavity wall, with the connection with the iron piece, but at the level of blocks, which is maybe not very visible immediately from the second illustration on your right, but in the corner of the building blocks, you have rooms that have no windows and no doors. And archaeologists were thinking, what is the purpose of this? And in fact, it's when there is an earthquake that occurs, these places are meant to collapse without killing people. They concentrate the energy, they dissipate the energy of the earthquake. And it's something very new, even for I would say, the modern science of earthquake resistance. That means to have fuse system at the level of building blocks and not at very specific place. Here you have another example, which is even older in the Peruvian environment, called Chicra, which is a kind of gabion system that were used in the basement of the building to isolate the building from its ground and to limit the impact of the earthquake. So there are many interesting development in the past that we think that could be very useful, changing our approach towards systematic use of reinforced concrete, knowing that the impact of the building sector on the climate change is a huge impact. And if you follow the standards, existing standards for everything that you need to rebuild after earthquake, you just have to, to maybe make, if it's possible, more stable construction, but you are going to make a much greater bad impact on the climate change. So this solution can have very interesting change. So here is to illustrate also what I said about the definition of archeosismology in terms of building as a marker. You see the 4 illustrations, and the third one represents the field of archeosismology that is between this paleosismology and seismic records that we have nowadays. And this is an illustration of a project that especially ISTER, with the support of the other partner of the cluster, are going to develop in the Jura area. From our side, we bring some example from Nepal. On the top, not on the top, on the 2 left illustration, you have what is called traditional stone masonry with a seismic band made of stone masonry, which is totally surprising because normally you use timber seismic bands, which indicate that in this place there are earthquakes, and the people knew, and they have evolved into the technology that they were using in the past to make the construction more resistant. And this is example of building that has resisted to the 2015 earthquake close to the epicenter. An example of what the research can bring into the reconstruction process. You have an illustration of one of the buildings that we developed with some academic and NGO partners during the earthquake reconstruction phase. This is you see is the physical aspect of the project, but there are also all the social aspect, how to deal with the community, to involve the local professionals, and the project is not a university or academic project from the north to the south, but really something that is co-built with the local stakeholders. Okay, some other illustration. We have the opportunity to regularly to do some survey after earthquake. Here you have another illustration of after the earthquake of Kahramanmaraş in Turkey 2023. Here in Osmaniye, the similar system using this seismic band made of timber into stone masonry, and to see that okay, you see some cracking, but the people that were inside the building were not in danger. Just the minaret collapse, which is, I would say, normal due to the volumetry of the building. But this is things that can be also reused. What is interesting also is to see what is the effect of the earthquake on, for example, stone masonry, that can confirm the hypotheses that were found in the Machu Picchu environment, for example, stone and block displacement, or on the picture that you see on your right, some specific breaking of one of the stone. Here you have again with in Turkey, which is the Kastabala archaeological site, also to see this old Roman city, small city with paved roads and columns, and one of the column collapsed in the specific direction that giving the direction of the waves, I would say of the earthquake, and we have been able to identify with our partners the fact that previous earthquake already made some of the columns to collapse or to break in the same direction. And we were able to correlate this with the history of earthquake in the region. Bridge can be also a Roman bridge here. It's the same earthquake in Turkey, Kahramanmaraş. In fact, there were two main earthquakes. But bridge, and example was given by Cécile about also the graveyards that are also damaged by the earthquake. So, what is the main, I would say, things what we try to do? We had the opportunity to to answer a call from the University of Grenoble, PGA, which is called the International Research Booster, which is called to support the reinforcement of strategic partnership that were existing. Here's a partnership between UGA and University of Oxford. University of Oxford have people working in the field of archaeology and geosciences. And here we have people working in the field of architecture, civil engineering, and geosciences. In our team, we have also archaeologists. So, and we knew each other due to some other project that we had in the past in the Central Asia. So we had all this reflection together, and we used these 2 years to think about the future of this, I would not say new sciences, but new field, in fact, what to do. So we organized the very first seminar in October between Oxford and Grenoble, but inviting also other university and researcher, like one researcher from Peru that is doing his PhD in Valencia in Spain, working on what is called COB, which is another earth construction techniques, and to see how Inca and pre-Inca civilization were taken earthquake into consideration in the process of construction, or also new sources of information like Codex. This is a research from colleagues from University of UNAM in Mexico that was also able to trace, and we can cross the information in between what is found on the field and the Codex and what we can do. But I'm sorry, it's not. It's very small, but in fact, it's the idea to try to structure the research path for the future, to identify the different problematic and to structure the research. The idea is to organize in October a final conference with different researchers from both university, Grenoble, Oxford, plus a number of other academic partners, to develop the research perspective regarding archeosismology, to structure the definition, I think, to have a kind of transdisciplinary state of art, to identify the specific issue that need to be tackled, like hazard prediction due to the fact that we have the return period, the vulnerability aspect, the modeling, the standards, the multi-scale resilience, and the idea for maybe to go from archeosismo to archeoclimate to hazard, and to map the future of research on the field of archeosismology. The aim is also to develop network, and we have a specific we have identified a specific terrain for research, which will be in Turkmenistan, in one well-known fault system, where we have 3 main cities, historical cities, and where we are going to work together and so on. And as part of this research process, we have also been able to, for the next conference at EPFL, this SAHC conference, to have a special session on archeosismology, where we will have a certain number of researchers. I hope I was clear and comprehensive. Thank you for listening, and I will see for the question afterwards. Thank you.